Okay, now that we are comfortable solving linear inequalities, we're going to solve a system of linear inequalities. The solution will be found in much the same way as it was for just a single inequality. What we'll do is we will graph the solution set for each of the individual inequalities and then find the overlapping region. If there is no overlap, then that system would have no solution. So let's take a look at the first example here. We'd like to graph the solution set for this following system of inequalities. So let's start by graphing 7x minus 3y equals 24. So let's see, I'm going to start by letting x equal 0, then the equation simplifies to negative 3y equals 24, and so y would equal negative 8. So this gives us 1 point on our graph at 0, negative 8. Now we want to do the same thing, but for y equals 0. This would simplify to 7x equals 24, and so x would equal 24 over 7. 24 over 7, 24 does not divide evenly by 7, but it's going to be a little bit bigger than 3, but smaller than 4, because 7 times 4 would be 28, and 7 times 3 would be 21. Okay, so this is going to be slightly bigger than 3. And then the remaining two equations, they're going to be either a vertical or a horizontal line, so we don't need to find x and y intercepts. So let's go ahead and graph our first inequality. And I'm going to use different colors for each one so we can see what the overlap is. So starting, we have 1 point at 0, negative 8. So 0, negative 8 will be on the y-axis. And then our second point would be at 24 over 7, right? We said that was approximately a little bit more than 3. So 24 over 7, comma 0. So I'll say here's 3. And so our point is going to be a little bit past it. Since we have greater than or equal to for the inequality, we can draw this line as a solid line. Okay. So here is our 7x minus 3y equals 24. That's the line that we've drawn. Let's see. X equals 0 would be the y-axis, just the vertical line at the y-axis. So here's x equals 0, and y equals 0 is the x-axis. So you can see that we're talking about we're going to try to find the overlap between each of these three regions. So let's work sort of backwards. Y has to be greater than or equal to 0. That means that anything in the top part of the coordinate plane is a valid solution, because anything above the x-axis has y greater than 0. Let's see, if x has to be greater than or equal to 0, then that gives us anything on the right half of the coordinate plane. So now we can see there is some overlap occurring just between these two. It looks like quadrant 1 is looking promising because we have overlap occurring in quadrant 1 between the two solutions. So now we need to know which side of the blue line is going to be a solution. And so now we'd want to pick a point that's not on the blue line. So since the origin 0, 0 is not on the blue line, let's go ahead and test the origin. So we're testing the point 0, 0 in the inequality 7x minus 3y greater than or equal to 24. So we would have 0 minus 0 greater than or equal to 24. That's false. And so that means that the solution set for the blue line has to be the side of the line that does not have the origin. So we're pointing sort of to the right and down away from the blue line. So the overlap then, the region that satisfies all three inequalities, is going to be this sort of triangular region over on the side right here. Come down to the x-axis, over to the side, and it keeps going in both directions there, to the right, and it keeps going up. This satisfies y greater than or equal to 0, because any point in this region has a y value that's greater than or equal to 0. It satisfies x greater than or equal to 0, because any x value on a point in this region would be greater than or equal to 0. And furthermore, it satisfies 7x minus 3y is greater than or equal to 24, because it was in the solution set for that inequality. So this yellow shaded in region would be our solution set for the system of inequalities. We call the solution set for a system of inequalities, we call this the feasible region. And any corners of the feasible region, so wherever a boundary intersects, we call that a corner point, or a corner of the feasible region. So right here at our 24/7, 0, that would be a corner point of the feasible region. Okay.